Hello and welcome to Dr. GMAT, your guide to scoring 700 plus on this exam. Today we will cover probability lesson number 3, which deals with independent and dependent events. We have already covered simple probability in lesson 1 and probability of multiple events in lesson 2. And they are available on YouTube. They are also available on my site www.drgmat.com. Let's look at independent and dependent events. What is an independent event? It's basically an event where you're not affecting the probability of another event. So both events are totally independent, like a coin toss, or coin tosses actually in this case. I can flip a coin as many times as I want, but that would not affect the probability of any of the coin tosses at all. And same thing will be true in the case of, for example, if I was to draw a card out of deck of cards and put it back in the deck of cards, the probability remains the same. A dependent event will be where the first event affects the probability of a second event. For example, if I take a card out of a deck of cards and don't put it back there, then I have affected the probability of a second draw. Before I have 52 cards, now I have 51 cards. The formula that we used in solving dependent probability questions is probability of A multiplied by probability of B given A. Let's look at an example and it will become clear to you. If someone draws a card at random from a deck and then without replacing the first card draws a second card, what is the probability that both cards will be aces? Now we know we have 4 aces in a deck of cards and total number of cards is 52. So in our first draw, we know 4 aces, we know total number of cards, so using simple probability, probability of event A is 1 over 13, as you can see here. Now what is the probability of event B? Because now I have 3 aces in the deck and I'm dealing with 51 cards, so the probability in this case would become 3 over 51. To calculate the probability now of that if both were aces, in the case when you did not replace the first ace back into the deck, will become 1 over 13, which is the probability of event A, and 1 over 17, which is the probability of event A given, probability of event B given A, and 1 over 221 becomes your answer. Now let's look at another example where if you have 30 red and blue marbles in a jar and the ratio of red to blue marbles is 2 to 3, what is the probability that drawing twice you will select 2 red marbles if you return the marbles after each draw? Now basically, since I'm replacing the red marble back into the jar, I'm not affecting the probability of my second event. So first of all, what I have to do, I have to figure out how many, since I'm given a ratio and a total number, I can figure out how many red marbles I have, how many blue marbles I have. So I can set up a simple equation and get the value of x, get the value of red marbles and blue marbles. Here I have 12 red marbles, 18 blue marbles. So if I was to draw a red marble using simple probability, I would get 2 over 5, as I have 12 red marbles, 30 is my total, so it becomes 2 over 5. And same thing will be true for second draw because I put it back in the jar, right? So the probability will stay the same, and here we're basically using independent event because we're not affecting the probability of the second event. So probability of A and B, and I mean, if you remember what we covered in the first lesson of simple probability, that what do you do in case of AND compared to in case of OR. In AND, where both events are to happen together, you multiply the probabilities. If both events can happen, either one can happen, then you add them. So here we have multiplied probability of event A and probability of event B, and we get 4/25. And to make it interesting, you can say, well, what if you don't put the first red marble back in the jar? I know a lot of people have trouble with this kind of question, but hopefully this will help you make your concepts better. In that case, the probability of the first event remains the same, 2/5. But in the second draw, now we're dealing with 29 marbles in the jar, and we already have taken one red marble out, so we have 11 red marbles left. So the probability of second one becomes 11/29. Now, using the formula that we have, where probability of A multiplied by probability of B given A would be 2/5 multiplied by 11/29, and your answer is 22/145. Again, to make it clear that if you return every marble, the probability of drawing another marble is unaffected. If you do not return the marble, then you're affecting the probability, and then you would use the formula that we just used, and it's a dependent event. Again, to crack quant, identify your weak areas, keep working on your weak areas, and you'll improve only by practicing and not by guessing. I would highly recommend Official Guide again, and keep watching my videos, and keep checking my website out. The next lesson is mutually exclusive events, so keep an eye out for that. Good luck, and I'll see you guys soon.